Today, we're going to be looking at some examples of chain rule applications. And we have four examples here, and they are ordered from difficulty from easiest to hardest. So, from sine of 2x. Well, to understand this derivative, we let us first just give a brief overview of what the chain rule is. The chain rule states that for any composite function's derivative, such as f of g of x will be equal to f prime of g of x times g prime of x. This is what the chain rule is, and with this definition of the chain rule, we can begin to find the differentiation of each function. So sine 2x. Well, first of all, what is the outer function and what is the inner function? Well, we see here that sine of x is a function, but the input of x is 2x. So our first function is sine x, and our second function is 2x. And the reason why I know this is because sine of x is a function, and that is just a trigonometric function, and 2x is just a straight line. So therefore, we have a composite function in the form of f of g of x prime. Therefore, we can use the chain rule to differentiate sine of 2x. So first, we differentiate the outer function as a whole, sine 2x. And we know the differentiation of sine is cosine. So sine of 2x's differentiation will be cosine of 2x. And what is the derivative of the inner function of 2x? Well, we know that for any linear line, such as 3x plus 5 or 2x plus 1, the derivative of that line will be the slope. So simply, it will be 2. Hence, the derivative of sine 2x will be equal to 2 times cosine 2x. And now we're ready to move on to example 2, the derivative of 3x plus 5 squared. Now, what we can do is we can expand 3x plus 5 squared out, but we're doing this as chain rule examples, so we're not going to do that. We're going to analyze the outer function, we're going to analyze the inner function. So what is the outer function of example 2? Well, that would be x squared. And why is that? Because x represents any input value, whether that be another function or just a single variable or integer. So the outer function is x squared, and the inner function is 3x plus 5, a line. And what is the differentiation of the outer function? Well, the outer function will be 3x plus 5 squared, or x squared. We know the differentiation of x squared is 2x. Hence, what is x? X is 3x plus 5, so this becomes 2 times 3x plus 5 as the first differentiation of the outer layer. Then we must differentiate the function within this outer function, which is 3x plus 5. And remember, the differentiation of any line will be that slope. So 3x plus 5's differentiation will be 3 to get us 6 times 3x plus 5 as our differentiated result of 3x plus 5 squared. And what is the derivative of sine of cosine of x? Well, as always, the outer function we must analyze first. So the outer function in this case is sine of x being cosine of x in this case. So the derivative of the entire outer function, which is sine of cosine of x, will be cosine of x. And then we must multiply this by the differentiation of cosine x, because cosine x in itself is another function. And the derivative of cosine x is negative sine of x. But are we really done yet? Because we have another function within cosine x, which is x. And that is a function because y is equal to x will be a linear line. And within linear lines, the differentiation of linear lines will be that slope. But the slope of x will be 1. So multiplying this by 1 won't really change anything. So the solution is still this quantity. And now for our final question. The derivative of x plus 5 squared divided by 4. So this is in the form of a quotient. Therefore, we must apply the quotient rule in order to differentiate this in respects to x. So the quotient rule, as a brief overview, where u and v represent functions, will be equal to u prime of v minus uv prime divided by v squared. Hence, what is v? V will be 4 in this case, hence v will be 16. And u prime, which is x plus 5 squared prime, will be 2 times x plus 5 times 4 minus x plus 5 squared times 4's derivative. But the constant derivative is 0, so we don't need to write anything. And then we must multiply this by x's derivative. But x's derivative is 1. And the reason why we take the derivative of x right here is because x is part of x plus 5, the inner function of x plus 5 squared. So this is multiplied by 1, which we don't really need to write, but for the sake of understanding and a conceptual understanding of the chain rule, I do so. And we see here that we can factor 2 and 16 becomes 8, and 4 goes into 8 twice. Hence, this becomes x plus 5 over 2, which is the solution to our question. And I hope that these examples right here have given you a little bit more of an insight towards how the chain rule is applied and used for within different functions. In future videos, we'll be diving into much more detailed and harder examples that will truly put you to the test of your understanding of the chain rule.